In this example, we're going to be looking at the equation y equals x minus x squared, the whole quantity squared. And we want to find the local and or absolute max over the interval from -1 to 1. And this is a closed interval. You'll notice the brackets on each of those values. So let's go ahead and start with finding the derivative of our function. So I'm going to go ahead and call this function f of x for right now. Keep in mind that when we take the derivative of this function, we're going to have to use the chain rule. So f prime of x, when we start taking the derivative here, we're going to get 2 times the quantity x minus x squared, all of that to the first power. And then we'll have to go ahead and take the derivative of the inside set of parentheses, which is going to give us 1 minus 2x. And just to make things a little bit easier at the next step, let's go ahead and factor the x out of this set of parentheses here. So we'll get 2, we'll take that x out. That's going to leave us with 1 minus x inside that set of parentheses. And we'll have the 1 minus 2x as our last factor. And let's go ahead and take our derivative and set this equal to 0. So 2x times 1 minus x times 1 minus 2x will be equal to 0. And we can set each of our factors equal to 0 to solve for our x values. So on the first one, we'll get x equals 0. We'll have the factor 1 minus x equals 0. And our last factor, 1 minus 2x equals 0. Solve each of these for 0. On this middle factor, we can add the x to both sides. That's going to give us an x value of 1. And on our last factor here, if we add the 2x to both sides, we'll get 1 equals 2x. Divide both sides here by 2, and we'll get x equals 1/2. So we have 3 x values that we're looking at here, x equals 0, 1, and 1/2. And keep in mind that we want to evaluate our function, the original function, so f of x, at the critical points and at the endpoints of your interval. Right, so let's go ahead and start with calculating f of -1. And be careful when you're plugging in your values here. Make sure you are squaring terms appropriately. So this will give us -1 minus -1 squared. That whole quantity will be squared. -1 squared will be a +1. We'll get -1 minus 1 inside the set of parentheses, which will give us a -2. That whole quantity will be squared, which will give us 4. Go ahead and take a look at our next x value, which is going to be f of 0. We're going to get 0 minus 0 squared, that whole quantity squared. This will come out to be 0. Let's go ahead and do the 1/2 next. So we'll calculate f of 1/2. This will be 1/2 minus 1/2 squared, and then this whole quantity will be squared. 1/2 squared is 1/4. So we've got 1/2 minus 1/4. That whole quantity squared. This will give us 1/4 squared, which is 1/16. And our last x value here, we'll do f of 1. This will give us 1 minus 1 squared, that whole quantity squared. 1 squared is 1. 1 minus 1 is 0. This will give us 0 squared, which is just 0. So as you're looking at these values, keep in mind your local and absolute max values are y values, right? And so you're going to be taking a look at the four values you just found. We have 4, 0, 1/16, and 0. So as we look at each of those, the 4 will probably be our absolute max, right? That's our largest y value on that interval. And then the 1/16 will probably be a local max, right? We can go ahead and take a look at the graph of our original function. Just make sure that you're verifying your answers. Make sure it matches up with the graph of the function and what you're looking at. So let's go ahead and graph this original function so we can take a look at our answers and how they match up to the graph itself. So I went ahead and logged into Desmos. I went ahead and graphed our original function. What you're seeing is a zoomed in image of the function itself. And we want to go ahead and look at the interval from -1 to 1. So I'm going to go ahead and put some boundary lines on our graph here. Here's our x value of -1. Remember that was inclusive, right? And x value of +1. So the section of the graph between these two boundary lines is what we were looking at. And you'll remember that we found a y value of +4, right? That occurred at x equals -1, right? So this would be our absolute max on the graph. That was our highest y value that we had, right? And it also asks us to identify any local maxes. You'll notice that when we had plugged in the 1/2, right, we ended up with a value of 1/16 as the y value. So this would be our local max on the graph itself. So if we return to this problem, right, our absolute max was this value of 4, right? And the 1/16 was our local max.